LeetCode Problem 94. Binary tree in-order traversal. Given the root of a binary tree, return the in-order traversal of its nodes' values. Example 1. The root is 1, 0, 2 and 3. The output is going to be 1, 3 and 2. Example 2. The root is 1, 2, 3, 4 and 5. The output is going to be 4, 2, 5, 1 and 3. The approach that we're going to be taking is called the iterative in-order traversal, which requires a stack data structure. It has a time complexity of O of n and a space complexity of O of h, where h is the height. This will be the optimal solution to this problem. Now let's walk through an example. 1, 2, 3, 4 and 5. Step 1, we want to declare 3 variables. A stack, which is an empty array, a result, which is also an empty array, and the current node, which is going to point at the first node in the tree. Step 2. While the current node is not null, or the stack has a length greater than 0, we need to do the following 2 things and apply this logic on the right hand side. So, while current node doesn't equal null, we can see that it's 1, so it doesn't equal null. We then push the current node to the stack. So we put 1 in the stack, and then we update the current node and set it equal to the current node dot left, which we can see is the 2. So we can see the current node is not null, so we want to push the current node to the stack. So we'll add the 2 node to the stack, and then we'll update the current node and set it equal to the left of the 2, which is the 4. And again, we check while the current node is not null, which it's not because it's pointing at the 4. We want to push the 4 node into the stack, and we update the current node to the 4 nodes left, which is null. So while current node is not null, it is null, so we can skip inside the while loop. We'll set current node equal to the stack pop, which is the 4. We then want to push the value of the 4 into the result, so we'll put 4 in there. We'll update the current node to point at the right of the 4 node, which is null. And back up here, we skip the while loop because it is null. We then pop from the stack. So we've now got the 2 node, which we popped from the stack. We then push the value 2 into the result. And we update the current node equal to 2 on the right, which goes to the 5. Then we say while it's not null, then we want to push the 5 node to the stack, update the current node to the left node of the 5, which we can see is null. So we ignore what's in the while loop because it is equal to null, and then we set the current node equal to stack pop, which is the 5. We then push the 5 to the result. We update the current node equal to the right side of the node 5, which we can see is null. So we skip the code in the while loop, and we set current node equal to the 1 that we've just popped off the stack. We then push the value 1 into the result, set the current node equal to the right node on the 1, which is the 3. And then we know the current node is not equal to null, so we push the 3 node onto the stack. We update the current node to equal the left node of the 3, which is null. So we check here in the while loop, so we can skip what's inside the while loop because it is null. We pop the 3 off the stack. We push the result of the current node's value, which is 3, into the result. And we set the current node equal to the right node of the 3, which is null. And now we can see that current node is equal to null and the stack has a length equal to 0, so we'll break out of the while loop. Step 3, we'll return the result, which is 4, 2, 5, 1 and 3, which is exactly what we were looking for. And that's it. It's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. LeetCode Problem 94 Binary Tree in-order traversal in JavaScript. Given the root of a binary tree, return the in-order traversal of its nodes values. Example 1. The input we're given is where root is 1, then null, then 2, then 3. We can see it visualized here, and the output is going to be 1, 3, and 2. So 1, 3, and then 2. Then example 2, we're given this input, which we can visualize here. And I'll show you the in-order traversal. So you go all the way to the left. So the first is going to be 4. Then we come up to the 2. So 4 and 2. Then we come down here and to the left, which is 6. You can see the 6. Then to the 5, to the 7. 5, 7. Then back up to the 1. Then we come here. There's nothing on the left, so we go with the 3. So 1 to 3, then to here, and then take the left, so 9, and then finally the 8. So 9 and then 8. So that's the in-order traversal. Then example 3, we are given an empty tree where root would equal null. And as we can see, the output is going to be an empty array. Obviously, if we're given an empty tree, then the integer array that we return is just going to be an empty array. Cool. Then example 4, we are given a single node in the tree, and basically what we want to do is we just want to return the value of that node in an array. So in terms of edge cases, there are 3 edge cases that I can think of that have been given in these examples. So example 3 gives an edge case where we're given an empty tree. In that scenario, you just want to return an empty array. Cool. Example 4 gives another edge case, which is where we are given a single node, and as previously mentioned, when we're given a single node, you just want to return an array with a single value in it, which is the value of that single node that we were given. And then example 1 covers another edge case, which is, if we look at the first node, we can see that it does not have a left node, it only has a right node. So we'd need to be able to manage that particular edge case. And similarly, if we look at the 2 node, we can see that it does have a left node, but does not have a right node. So again, the problem, our solution, needs to be able to handle that edge case. Cool, now let's get into it. So the first thing that we want to do is we want to declare 3 variables. So the first one we'll use is going to be a stack. We'll set that equal to an empty array. Secondly, we want to have the result, which is what we're going to return. So again, we'll have that as an empty array. And then finally, we want the current node, which is what we're going to use to track the current node that we're on in our traversal. So we'll set that equal to root, and then we want to loop over every node in the tree. So to do that, we're going to use this first while loop, which we're going to say while current node or stack.length is greater than 0. And then while we're in here, we then want to traverse to the leftmost node. So to do that, again, we'll use a while loop. We'll say while current node. Then what we want to do is we want to take the current node and we want to push it onto the stack. So stack.push current node. And then we want to update the current node to current node.left, because as I said, we're going to the leftmost node. So current node equals current node.left. Okay, cool. Then once current node is equal to null, it means that we've obviously reached the leftmost node because we've hit null, which means we can't go left any further. So once we've done that, then what we want to do is we want to pop the last node that we added to the stack. So we set current node equal to stack.pop, and we want to process this node. So to process this node, what we want to do is we want to add it to the result. So result.push current node.val. And then because we've gone to the leftmost node, what we want to do now is we want to go to the right hand side, so to the right hand node. So we'll set current node equal to current node dot right, and that is everything that we want to add inside of this while loop. So as we've got this logic here, which is current node is not null, if current node is equal to null and the stack dot length is equal to 0, that means that we've fully traversed all of the nodes in the list, and basically we just want to then return the result. Alright, cool. Now let's run that. That's run. Now let's submit it, see if it passes the edge cases and how it performs. Great. So it says it beats 100% in terms of runtime, and it beats 81.4% in terms of memory. I can tell you that the runtime complexity is O of n, because it has to hit every node in the input or in the tree. And the space complexity is O of h, where h is the height of the tree. Because as it goes to each level of the tree, it's adding to the stack. So if there were 100 levels, you're going to add 100 nodes to the stack. Hence the O of h memory complexity. This is the optimal solution to this problem, and I hope that this has clarified it for you. If you liked the video, please click like, and if you could click subscribe, that's going to hugely help me and this channel out so that I can spread these tutorials to a wider audience. And if there's anything that you think I can improve on, or any videos that you'd like to see in the future, please leave them in the comments below and I will get back to you. Thank you very much for watching, and good luck with your coding.